Look at the historical photographs of the 1890s. The United States was a nation running on horses, coal, and mud. The primary mode of heavy overland transport was the wooden wagon. The cutting edge of domestic technology was the gas lamp. Now look closer. Colossal stone architecture, 35-ton precision-machined generators, a 21st century alternating current power grid built directly under a boiling, violent waterfall. Pickaxes and hand shovels do not build megalithic power plants, and primitive steam winches do not lower 70,000 pounds of solid steel with millimeter precision. History asks us to believe that pioneers and businessmen leaped from localized steam engines to the modern electrical age in just 5 years. Today, we audit the Niagara Falls anomaly. First, the mathematical impossibility of the subterranean excavation and the hydrostatic nightmare of the Niagara River. Next, the heavy brick paradox and the biological limits of the human workforce. Finally, a catastrophic mechanical anomaly proving the official ledger is a mathematical fiction. You are watching Titan Metrics. The file is unlocked.
Let us start with the accepted historical narrative. The Edward Dean Adams power plant was commissioned in 1890 and was officially generating power by August 26, 1895. We are told that in a span of just 5 years, a group of businessmen and engineers conquered the brutal geology of the Niagara River. Mainstream history treats this facility as a triumph of industrial-era determination. They focus heavily on the names: Nikola Tesla, George Westinghouse, J.P. Morgan. But history books rarely run the math. They focus on the romantic genius of alternating current, but they completely ignore the mud, the water, and the physics of the 1890s supply chain. Let us audit the foundation. To harness the colossal power of the Niagara River, the engineers could not simply place a water wheel on the bank. They needed to drop millions of gallons of water onto massive turbines positioned far below the surface. This required excavating a vertical slot cut directly into the earth, parallel to the raging river. They called it the wheel pit. According to the engineering specifications from the Cataract Construction Company, the main wheel pit was excavated to a length of 400 feet, a width of 21 feet, and a staggering depth of 135 feet. This was not dug through soft topsoil. This was carved through dense Niagara limestone and Rochester shale. But before we even calculate the mass of the rock, we must calculate the volume of the water. Look at a geographic map of the site. The wheel pit was dug essentially on the shoreline of the Niagara River, just above the falls. The water table is absolute. When you dig a 135-foot trench directly next to one of the most powerful, high-volume rivers on the planet, the water does not politely wait for you to finish. Millions of gallons of freezing, pressurized groundwater aggressively bleed through the fractured limestone fissures, actively trying to fill the void. To keep the workers from drowning, the pit must be pumped constantly, 24 hours a day. In 1890, there were no high-capacity submersible electric pumps. They had to rely on heavy, coal-fired steam pumps. To extract millions of gallons of water a day from a deep pit requires a massive, unbroken thermodynamic chain. If the steam pressure drops, if a cast iron gear fractures, if the coal supply is delayed by a winter blizzard, the pumps stop. Within hours, the pit entirely floods, drowning the men and destroying the excavation equipment. You are fighting the entire volume of the Niagara River using 19th century steam power. Assuming they miraculously maintain dry ground, let us run the baseline geometry of the rock extraction. 400 multiplied by 21 multiplied by 135. That gives us a total geometric void of 1,134,000 cubic feet. To understand the true logistics of moving this material, we must convert it to cubic yards. That is 42,000 cubic yards of solid bedrock. But solid rock is highly deceptive on paper. Solid limestone weighs roughly 4,400 pounds per cubic yard. When you blast solid rock with black powder, it fractures, breaks apart, and expands. Forensic engineers call this the swell factor. For dense limestone, the swell factor is approximately 60%. This means our 42,000 cubic yards of solid rock immediately became nearly 67,000 cubic yards of jagged, loose rubble. How do you lift 67,000 cubic yards of heavy rock straight up out of a narrow, deep trench in 1890? You cannot use ramps. The pit is completely vertical. You must use steam-driven wooden derricks and iron buckets. Assuming a standard heavy-duty construction bucket of the era could hold half a cubic yard of heavy, jagged rock, that requires 134,000 individual bucket lifts. 134,000 flawless, uninterrupted vertical lifts. If they ran the hoists 365 days a year for 2 full years just on this single pit, they would need to complete 183 bucket lifts every single day, without mechanical failure, without snapped hemp cables, and without massive delays for blasting, clearing the toxic smoke, and shoring up the walls. And once that heavy bucket reached the surface, the rock did not just magically disappear. It had to be loaded onto horse-drawn carts. A standard 2-horse team pulling a reinforced wooden wagon over unpaved, muddy 19th century dirt roads can safely carry about 1 to 1.5 cubic yards of rock. That translates to approximately 50,000 individual wagon trips. Imagine the logistics of 50,000 horse-drawn wagons cycling through a cramped, freezing, muddy construction site on the edge of a rushing river. The sheer volume of animal feed required, the management of horse manure, the physical exhaustion of the animals. It is a logistical nightmare. And yet this massive wheel pit is just the beginning. The real impossibility lies much deeper. Once the river water drops 130 feet down the wheel pit and spins the turbines, it has to go somewhere. It cannot stay at the bottom of the shaft, or the pit will instantly flood and the entire power plant will cease to exist. To solve this, the official narrative claims the builders excavated a colossal subterranean tail race tunnel to carry the exhaust water away and dump it downstream into the lower Niagara River gorge. The dimensions of this tunnel are mathematically staggering. It is 7,000 feet long. That is 1.3 miles of continuous underground excavation. It is shaped like a massive horseshoe, standing 21 feet high and nearly 19 feet wide. It was bored at a specific grade, entirely through solid rock, deep beneath the populated town of Niagara Falls. To create a tunnel of this immense size, you are excavating roughly 14 cubic yards of rock for every linear foot of forward progress. For a 7,000-foot tunnel, that is nearly 100,000 cubic yards of solid rock. Apply the swell factor of 60%. You now have 160,000 cubic yards of loose, jagged debris. The historical record asks us to believe that men went down into this toxic, pitch-black environment, hand-drilled deep holes into the limestone, set high explosives, and then shoveled 160,000 cubic yards of shattered rock into small carts. Mainstream historians and engineering textbooks will immediately point to the technology of the era. They will tell you that the workers used early pneumatic drills, like the Burley drill, powered by compressed air piped down from the surface. They claim the cold exhaust air from these drills provided natural ventilation, pushing the toxic smoke out of the tunnel. Let us run the volumetric math on that alibi. We are talking about a dead-end tube, 21 feet high, stretching over a mile underground horizontally. Blasting solid rock with early dynamite generates millions of cubic feet of toxic carbon monoxide, thick silica dust, and explosive residue. The exhaust from a handful of pneumatic drills does not create a massive high-velocity wind tunnel, it creates a localized breeze. To physically flush millions of cubic feet of heavy, toxic smoke horizontally for 7,000 feet against atmospheric resistance, you need massive industrial electric impeller fans. Piped compressed air simply stirs the dust, it does not extract it. The human body is a biological engine. You cannot shovel thousands of tons of heavy stone in a mile-long dead-end pipe filled with carbon monoxide, relying on the hiss of a drill for oxygen.
The biological limits of the workforce completely contradict the speed of the excavation.
But excavating a 1.3-mile rock tunnel under a city was only the first half of the anomaly. The engineers knew that raw Rochester shale degrades rapidly when exposed to rushing water and atmospheric air. If left unlined, the 7,000-foot tunnel would erode, fracture, and collapse within months, taking the town above down with it. So they lined it with brick. The official records state that the tail race tunnel is lined with an average of 4 courses of high-grade, hard-burned bricks, 4 solid layers thick, covering the entire perimeter of a 21-foot-high, 19-foot-wide horseshoe for 7,000 linear feet. The accepted historical total for this specific tunnel is 16 million bricks. Let us put 16 million bricks into our virtual calculator and run the math on what that actually looks like in the real world. The entire excavation and lining of this tunnel was supposedly completed between late 1890 and the end of 1892. Let us give the official ledgers the absolute maximum benefit of the doubt and say the bricklaying phase took 2 full years, 730 continuous days with no days off for extreme winter weather, labor strikes, or supply chain failures. To lay 16 million bricks in 730 days requires setting 21,900 bricks every single day. Mainstream historians will aggressively defend this timeline. They will argue that the contractors hired hundreds of master masons and thousands of laborers, working 24 hours a day in continuous shifts under the glow of early electric arc lamps. But logistics is not constrained by the number of men you can hire. Logistics is constrained by spatial geometry. Let us audit the physical space. The tunnel is a horseshoe shape, 19 feet wide. It is a single, narrow, subterranean artery. You cannot physically fit hundreds of masons, their curved wooden scaffolding, their tools, and a continuous supply chain of 21,000 bricks and wet mortar into a 19-foot tube simultaneously. It creates an absolute spatial bottleneck. The more men you pack into a dark, freezing, wet tunnel, the slower the work progresses due to traffic jams. You have horse-drawn carts trying to bring fresh mortar in, while empty carts are trying to get out. You have masons fighting for physical elbow room on wet scaffolding. You cannot bypass the geometric limits of the workspace. 16 million bricks, 36,000 tons of dead weight, mixed, transported, and perfectly laid in the freezing mud of a mile-long tube. In 1891, using hand trowels and horsepower, it borders on the mathematically impossible. Let us leave the mud and the brickwork and move to the mechanical phase. By 1894, the wheel pit and tunnel were allegedly finished, and it was time to install the machinery. The water dropping down the pit was directed into massive double-runner Fournieron turbines designed in Switzerland and cast in America. These massive turbines sat at the very bottom of the flooded pit. 130 feet above them, on the powerhouse floor, sat the revolutionary alternating current generators built by the Westinghouse Electric Company. The generators and the turbines were connected by vertical steel drive shafts. These vertical shafts were not simple iron pipes. They were solid steel tubes, 38 inches in diameter, spanning 130 feet vertically. They had to spin at exactly 250 revolutions per minute. Let us talk about rotational physics and harmonic vibration. When you have a heavy steel column spanning 130 feet vertically, any micro-wobble in the machining creates catastrophic kinetic energy. A steel shaft of that immense size, spinning off-axis by even a fraction of an inch, would vibrate the thrust bearings to dust and tear the generator apart. Historical engineers will argue that late 19th century belt-driven lathes were incredibly rigid, and skilled machinists using analog micrometers could achieve tolerances of 1/1000th of an inch. Let us grant them that precision in the factory, but the anomaly is not found on the factory floor in Pittsburgh. The anomaly is found in the dirt of Niagara. The revolving field ring of the generator weighed 35 tons, 70,000 pounds of solid forged nickel steel. Even if you machine a 35-ton block of metal perfectly in a factory,
How do you transport it hundreds of miles on primitive rail cars, drag it through the mud of a 19th century construction site, suspended over a 130-foot open pit on hem ropes, and lower it onto a drive shaft without causing a single microscopic warp, bend, or misalignment? A micrometer in a clean factory cannot save you from the brutal, unrefined kinetic shock of 19th century field logistics. One snapped cable, one sudden drop, one microscopic failure in a cast iron gear tooth holding the crane, and 35 tons of steel plummets 130 feet, destroying the foundation and killing everyone below. Yet the official narrative claims they installed these massive, unprecedented units consecutively, flawlessly, perfectly aligned, and without a single recorded catastrophic failure.
When you isolate each individual element of the atom's power plant, the official story sounds plausible to a layman. Yes, people dug holes in the 1890s. Yes, people laid bricks. Yes, people cast heavy iron. But logistics is not about isolated tasks. Logistics is about compound variables. You have to stack the variables. Excavating 160,000 cubic yards of rock from a dark, suffocating tunnel, while simultaneously digging a 135-foot vertical trench next to a raging river, while coordinating the continuous arrival of 16 million individual bricks via horse and wagon, while mixing tens of thousands of tons of mortar in the freezing cold, while constantly pumping out millions of gallons of groundwater, while waiting for the delivery of 35-ton precision-machined generators from Pittsburgh, while assembling thousands of intricate bronze turbine parts at the bottom of a wet, freezing pit. And you have to do all of it flawlessly, using primitive steam, exhausted horses, and manual labor in less than 5 years. This is where the mathematical audit completely destroys the historical narrative. The math simply does not support the timeline. The infrastructure required to build the infrastructure did not exist. To execute a project of this massive volumetric scale and extreme mechanical precision within this tightly compressed time frame, you need heavy diesel machinery, high-capacity electrical grids, tungsten carbide drilling equipment, and computerized supply chain management, none of which officially existed in 1890.
So, what are we actually looking at when we examine the archives of the atom's power plant? History asks us to accept a sanitized, romantic ledger, but common-sense logic requires physical evidence. If the accepted methods of 1890s construction cannot mathematically account for the speed, the mass, and the precision of the build, we are forced to ask a much heavier question. Are we looking at the construction of a new facility? Or are we looking at the excavation, retrofitting, and recommissioning of an existing, older infrastructure? When you look at the perfect, megalithic arches of the tail race tunnel, when you calculate the biologically impossible bricklaying rates and the suffocating atmosphere of the subterranean excavation, you have to wonder if the 16 million bricks were actually laid by Gilded Age laborers, or if those laborers were simply sent down to clear out the mud, pump out the water, and meticulously document a megalithic tunnel that was already there. The history books give all the credit to Morgan, Westinghouse, and Tesla. They tell a neat, perfectly packaged story of American ingenuity. But the rock doesn't care about the story. The brick doesn't care about the patents. The math of mass, volume, and time remains absolute. The Edward Dean Adams power plant was not a miracle of the 1890s. It is a statistical and logistical anomaly, a mathematical impossibility sitting right on the edge of the Niagara River, which leaves us with the ultimate silent implication. If human myology and horse-drawn carts could not carve this megalithic complex in 5 years, what exactly did Nikola Tesla find buried under the waterfall? Until the official timeline can reconcile with the physical arithmetic of the construction, the true origins of this megastructure remain hidden in the archives. But if you think digging a 1.3-mile tunnel under Niagara Falls defies common sense, you haven't looked at the subterranean matrix of the East Coast. Just a few years later, an American syndicate claimed to execute a completely different kind of subterranean slaughter. They claim to excavate 3 million tons of earth and solid bedrock directly beneath New York, the most congested, heavily populated, skyscraper-filled city on Earth, and they supposedly did it using the exact same primitive tools without causing the city above to collapse into the void. The forensic audit of the New York subway's 3 million-ton cover-up is opening on your screen right now. The investigation continues.